Imagine building a spaceship where every screw, circuit, and bolt must be planned before a single piece of metal is cut. There's no room for guesswork, no time for on-the-fly adjustments. This is not a creative brainstorm, it's engineering precision. This is the world in which the waterfall model was born. While today's fast-paced tech culture prizes adaptability and speed, waterfall remains a powerful, structured methodology, especially where predictability and control matter more than flexibility. The waterfall model is one of the earliest and most structured project management and software development methodologies. Originating from engineering disciplines and adopted into software during the mid-20th century, waterfall is defined by its linear, phase-based approach. Each stage in the development lifecycle flows into the next, like water cascading down a stepped cliff, hence the name. Rooted in system engineering logic, military-grade precision, and scientific rationalism, the waterfall model represents a philosophy of control, documentation, and predictability. It assumes that a well-designed plan, executed with discipline, can deliver complex systems with minimal risk and maximum accountability. Despite criticism in modern Agile-dominated contexts, waterfall remains highly relevant in sectors where change is a liability, not a luxury. Sequential development theory. The foundational idea behind the waterfall model is that project development progresses in a logical, step-by-step manner. This theory envisions a project as a sequence of distinct stages, each cascading into the next only once the previous is completed. This mirrors the way water flows downwards over the edge of a cliff. Once it descends, it does not return to the previous level. The phases generally follow this order: requirements, design, implementation, testing, deployment, and maintenance. In theory, each phase is self-contained and ends with a formal sign-off, indicating that the deliverables have met predefined standards before progressing further. This linearity ensures discipline and reduces ambiguity, especially in projects where requirements are clearly defined from the outset. It's a model often used in engineering, construction, and defense industries, areas where rework is expensive or dangerous. System Development Lifecycle, SDLC, Foundation Waterfall originates from the traditional System Development Lifecycle, SDLC, which is a framework used for structuring, planning, and controlling the process of developing an information system. It was particularly prominent in large-scale systems development during the mid-20th century, influenced by military and aerospace projects. The SDLC emphasizes meticulous planning, sequential execution, and robust documentation. In this context, waterfall is seen as the strictest and most structured implementation of SDLC. It assumes that development is best managed through clear-cut phases that reflect a progression from conception to operation. The SDLC foundation underpins waterfall's emphasis on accountability, traceability, and predictability, key requirements for government and enterprise-level systems. Formalism and documentation theory. A crucial theoretical component of the waterfall model is the belief in the power of formal documentation. Each phase produces exhaustive and structured documents, such as the Software Requirement Specification, SRS, High-Level Design, HLD, and test plans, that not only guide the next stage but also serve as contractual artifacts between stakeholders. These documents are not mere internal tools. They become binding agreements between clients, project managers, developers, and testers. This heavy reliance on documentation is designed to mitigate risks, clarify responsibilities, and eliminate ambiguities. It aligns with the idea that a well-documented plan is more defensible and manageable, especially in contexts where changes are costly or undesirable. The documentation-centric approach also enables new team members to join a project midway and understand its trajectory without needing tribal knowledge. Big Design Upfront, BDUF. One of the waterfall model's most defining theoretical assumptions is the principle of big design upfront, commonly referred to as BDUF. This principle holds that the best way to ensure project success is to understand and document all requirements and design details thoroughly before any actual development begins. The underlying belief is that the cost of fixing errors increases exponentially the later they are discovered in the development cycle. Therefore, anticipating potential issues and designing around them in advance is considered more efficient than iterating during development. BDUF was particularly favored in industries where systems integration, safety compliance, or legacy compatibility were major concerns. Critics argue that BDUF stifles innovation and adaptability, but proponents see it as the cornerstone of stability and control. Predictive Project Management Waterfall aligns closely with the predictive model of project management, which assumes that the future is knowable and controllable through detailed planning. In predictive project management, time, scope, and cost are defined early and are expected to remain relatively fixed. This approach fits well with Waterfall, where the idea is to prevent surprises by anticipating and documenting everything up front. Schedules, resource allocations, and milestones are tightly planned, and any deviation from the plan is treated as an exception requiring formal change control procedures. This predictability is highly valued in regulated industries, government projects, and sectors where budget overruns and schedule delays can have severe consequences. Project managers are empowered not by their ability to adapt quickly, but by their command over the plan and their enforcement of process discipline. Verification and validation, V&V. Theory. The waterfall model builds on the verification and validation theory, which posits that both building the product right, verification, and building the right product, validation, are essential to success. In practice, this means that each stage of the waterfall process includes mechanisms for checking that the work aligns with specifications and requirements. For instance, after the design phase, design reviews are conducted to ensure alignment with the requirements documented earlier. Similarly, the testing phase validates the implementation against the original requirements. This methodical emphasis on V&V ensures traceability of every requirement through the design and into the final system, thereby minimizing the risk of overlooked features or functional gaps. The separation of verification and validation into distinct phases is seen as a safeguard against human error and miscommunication. One-way flow with limited feedback. Perhaps the most distinctive and controversial theoretical tenet of the waterfall model is its limited allowance for feedback or iteration. Once a phase is completed, revisiting it is generally discouraged or restricted. The underlying assumption is that good planning and thorough analysis can foresee and solve most potential problems before they arise. Feedback is expected to be incorporated during phase transitions and sign-off meetings, not during the execution of a phase. This one-way flow ensures clarity and simplicity but also leads to inflexibility, making it difficult to accommodate evolving user needs, new business goals, or emerging technologies mid-project. In this model, change is treated as a risk rather than an opportunity, and managing it typically involves formal change request procedures rather than adaptive iteration. Origins of the theory. Although the waterfall model is often associated with rigorous engineering practices, its first formal depiction came from Winston W. Royce in a 1970 paper titled, Managing the Development of Large Software Systems. Interestingly, Royce introduced this model as a cautionary example, illustrating its limitations if used without feedback loops or iterative planning. Despite this, the visual simplicity and logical structure of the model led many organizations to adopt it as a best practice approach, particularly in the pre-Agile era when software systems were expensive, documentation-heavy, and mission-critical. Over time, variations emerged, such as the V model or incremental waterfall, which attempted to address some of the rigidity by introducing controlled iterations or parallel validation. Philosophical underpinning. The waterfall model rests on a philosophical foundation rooted in determinism and rationalism. It assumes that a system's behavior can be fully understood and specified before it is built. If all conditions, requirements, and constraints are known, then the development process can be carefully mapped and controlled to yield a predictable outcome. This philosophy also leans heavily on reductionism, the idea that complex systems can be understood by analyzing and solving their parts in isolation. In essence, Waterfall sees a project not as a journey of discovery, but as a construction project with a blueprint. This philosophical stance stands in contrast to Agile methodologies, which accept uncertainty as a core condition and treat development as a process of ongoing learning and adaptation. The waterfall model remains one of the most influential methodologies in the history of project management and software development. While often critiqued in the modern era for its lack of flexibility, its strength lies in its discipline, structure, and predictability. It is especially powerful in industries where rigid compliance, stable requirements, and high risk avoidance are essential. Understanding the theory behind Waterfall not only provides historical insight into how complex systems were once built but also offers valuable lessons in how control, documentation, and foresight can be leveraged for stability. Even in today's agile world, there are still scenarios where Waterfall isn't outdated, it's simply the right tool for the right kind of project.